In example 2, we want to design a voltage divider such that V2 is equal to 0.8 Vs and no more than 1 milliwatt of power is supplied by our voltage source, given our source voltage is equal to 20 volts. To begin, we want to express R2 in terms of Vs and R1. That is to say, our voltage potential across R2 would be equal to our resistance R2 per the sum of our resistances in series, R1 and R2, times our source voltage. This quantity has to be equal to 0.8 Vs, as given by our design statement. We can solve for R2, which is equal to 4R1, or we can express R1 in terms of R2, such that R1 is equal to 0.25 R2. Now we have to determine our current running through our circuit network. To do such, we'll apply Ohm's law, where I is equal to voltage potential per the resistance of the element of interest, which is equal to Vs per R1 plus R2. In recognizing R1 is equal to 0.25 R2, we can say our current running through our system is equal to 20 volts per 1.25 R2. The power supplied is simply our current times our voltage, where our current is equal to 20 volts per 1.25 R2, and our voltage is equal to 20 volts. Thus, our power supplied is equal to 400 times the quantity volts squared per 1.25 R2, and this should be less than 0.01 watts. In doing such, we can solve that R2 has to be greater than 320 kiloohms, and we have an expression for R1 being equal to 1/4 R2. Thus, we've designed a voltage divider such that no more than 1 milliwatt of power is supplied by our source, given that V2 is equal to 0.8 Vs.